Direct variation. First, we're going to go over some definitions. A direct variation function can be represented as y equals k times x, k being some constant number. The constant of variation is the constant rate of change in the function. In these first examples, we want to just decide if this is direct variation. To do that, we just want to solve for y and see if it is of the form y equals k times x. If it's of that form, then it is direct variation. So to solve this first one for y, we're going to divide by 7. And we have y equals 2 over 7 times x. So yes, that is direct variation. And there is a constant, k, of 2 over 7. In the next one, when we're solving for y, we're going to start by subtracting the 4x. And we have 3y equals negative 4x plus 8. Then we divide by the 3. And we have y equals negative 4 thirds x plus 8 thirds. So this is not direct variation because you're adding something else to the x. Okay, we're going to solve this next one. Is it direct variation? So we subtract the 5x over. And we have 3y equals negative 5x. And then we divide by the 3. And we have y equals negative 5 thirds x. So yes, this is direct variation because it's a number times x. Even if it's negative, it still works. So we would say yes, and then our constant is negative 5 over 3. And the next one, we have y equals x over 9. Well, this is really just y equals 1/9 times x. So we have the number 1/9 multiplied to the x. So the answer is yes. This is direct variation with a constant k of 1 over 9. In this next example, we're doing the same thing to see if it's direct variation, but we're given a set of points instead. So these are our points. And if it's direct variation, it has to go through the point 0, 0. So I threw that point in too. So now I'm going to find the slope between these 2 points. 2 minus 0 over 1 minus 0 would be 2 over 1, which is 2. So the rest of them all have to be 2 in order for it to work out. So I'm going to take the 6 minus 0 over 3 minus 0. And that would be 6 over 3, which is also 2. And we got to just try the last one now. 8 minus 0 over 4 minus 0 would be 8 over 4, which is also 2. So because all of the slopes are the same, and it does go through the point 0, 0, we can say yes, it's direct variation with a k constant of 2, and we know that it goes through the point 0, 0, because that was the point we kept on trying. This next example is the same. All we have to do is we're going to add that point 0, 0 to see if it is part of it. And then we're just going to find the slopes between each of them in 0, 0. 4 minus 0 over 1 minus 0 is 4 over 1. which is 4. 8 minus 0 over 2 minus 0 is 8 over 2, which is 4. And 11 minus 0 over 3 minus 0 is 11 over 3, which that is as simple as you can do it. So since all of these slopes are not the same, we would say no, it is not direct variation, because the slopes are not the same. Okay, these next couple are word problems that we just have to set up in a direct variation. Suppose y varies directly with x. So y equals kx. That's something we know. And we know also are given that when y is 35, x is 5. So 35 equals whatever my k is times my 5. So on these, I need to just find my k first, then plug it back in, then I can find whatever I'm looking for. So in this case, k is equal to 7, because you solve it for k. And then I can put it into my y equals 7x. And then I'm going to solve for the question that it asks. Find the value of y when x is 9. So y equals 7 times 9, because x is 9. 7 times 9 is 63, so y equals 63. This next one is the same. We know that y varies directly with x. So when y is 10, x is negative 2. So we need to find k. Divide by the negative 2, and k is negative 5. So then I put it into my formula. Y equals negative 5 times x. Find the value of y when x is negative 15. Y equals negative 5 times negative 15. And we're going to solve for y. So negative 15 times negative 5 is a positive 75. So y is equal to 75. These last couple might be a little more complicated, but the same idea. We're setting up a direct variation problem and then sketching a graph. The weight on Mars, y, varies directly with the weight on Earth, x. So the weight on Mars varies directly as the weight on Earth, x. The weight of science instruments on board the Phoenix Mars lander on Earth weigh 130 pounds and on Mars weigh 50 pounds. If the ship commander weighs 175 pounds on Earth, how much does he weigh on Mars? So first we're going to find the formula here. So we know that the tools weigh 50 pounds on Mars when they weigh 130 pounds on Earth. So we solve for k, and k equals 50 over 130, which is also simplified to 5 over 13. So my equation would be y equals 5 over 13 times x. And that's what I'm going to graph here. So it'd start at 0, 0, and we'd go up 5 and over 13. So it's like way over here. It's a really flat line like that. Be something like that. And if you could just get something close, that would be good enough at this stage. Okay, and then the question is asking for the weight of the astronaut, the commander on Mars. So we know that he weighs 175 pounds on Earth, so y equals 5 over 13 times 175 on Earth. And then you type that into your calculator. On Mars, he weighs 67.3 pounds. This next example, a salesperson's commission varies directly with the sales for $1,000 in sales. The commission is $85. What is the commission for $2,300 in sales? So the commission varies directly as the sales. So when the commission, when there's $1,000 in sales, the commission is $85. So we need to find the K in this case. So we divide by 1,000, and K equals 85 divided by 1,000. And if you wanted to put that in a decimal form, then 0.085. Okay, and then we're going to plug it in to find the commission for $2,300 in sales. So commission equals 0.085 times 2,300. And then you type that in your calculator, and the commission is $195.50. The number of calories varies directly with the mass of the cheese. If 50 grams of cheese contains 200 calories, how many calories are in 70 grams of cheese? So the number of calories varies directly as the mass of the cheese. So if there are 200 calories, the mass is 50. So we need to find our K, divide by the 50, and K equals 4. All right, and then we are going to plug that in to find what 70 grams of cheese would be in calories. So calories is going to equal 4 times 70. 4 times 70 is, type it in the calculator, and you get 280 calories. So that'd be your final answer. That is it for the notes over direct variation. You should be able to summarize those and come up with any questions you have and let me know. Work on the worksheet, and then you'll have a quiz.